Today we're going to be looking at the motion of a ball as it rolls down the ramp. We're going to be using Photogates today to determine the time the ball is traveling from its start point to the end of the ramp. And the distance between the Photogates will be the change in position of the ball. Photogates are going to be the means by which we determine the time. So here's a Photogate. On each side of the Photogate at the bottom, you see that dark hole. There's one on that side. There's the one on the other side. There's a light beam that travels from one to the other. When the beam is broken, that will either start the timer or stop the timer for the Photogate. And so we get a very precise timing for our ball. We want to have the Photogate the same position at the top of the ramp and the bottom of the ramp relative to the ramp. So what we're going to do is use finger or thumb or something like that and identify the height above the ramp where the bottom of our Photogate is. That way we'll be consistent in having the beam break the ball at the same place each time. So our ball is going to come through. We want it to be positioned so that when the ball rolls through the Photogate, the beam is broken by the widest part of the ball. So when we're looking at it end on, we want the widest part of the ball to be breaking the beam of the Photogate, both at the top of the ramp when the ball starts and at the bottom of the ramp where the ball is finished with its run. We want the Photogate to be positioned, the bottom Photogate to be positioned at the end of the ramp, helping us to find the speed of the ball when the ball has traveled the entire length of the ramp that we're measuring. The Photogate at the top of the ramp is going to be the one that gets moved. The Photogate at the bottom of the ramp is going to stay in one position. So that when we start the ball, we want to get it as close to the beam as possible without breaking the beam, because we want time to start when the ball is going as close to zero as possible. For collecting our time data, we're going to be using a CBL, which is the item on the left, and graphing calculators. The CBL is hooked up to those two Photogates, and the graphing calculator is hooked up to the CBL. The CBL has all the programming and the memory, and the graphing calculator screen displays the time that it takes the ball to go from Photogate 1 to Photogate 2, and so that's the time we're going to record. When these Photogates are ready to use, the red light on the top of the Photogate is going to be on, and when the ball goes through it initially, it'll get a little bit brighter, but it will stay on. When it goes through the bottom Photogate, the light will go off. Once the light goes off, we can look at the calculator screen and we can see the time that it took the ball to go from the first or the top Photogate to the bottom Photogate. There are printed instructions that'll be at each lab station for using the CBL and calculator, getting them set up and ready to go. Remember, the important things are keeping that bottom Photogate stationary. You're going to be changing the position of the top Photogate to time how long it takes the ball to go different distances down the ramp, and that's what we'll be graphing, is the starting position of the ball and the time it takes to get down to the bottom of the ramp. The bottom of the ramp we're going to treat as our origin, or zero.